I'm going to kind of start the ball rolling. This afternoon will be a kind of chronology of products and more or less in the order we produce them. Brenda Lundberg talked about reference data early on, so existing and potential vegetation maps are next. And I'm trying to put it in the context of just an idea that kind of came from some folks at RSAC and particularly Ken Brewer of any geospatial mapping project kind of in the context of classification, mapping, and inventory. And classification being what you're mapping, the actual mapping process, and the inventory of plot data, because generally all our products are plot data driven, and some of the things that we do with that. So starting the ball rolling, I think Matt had a similar slide. A lot of our products, fire behavior and fire ecology, are pretty much leveraged from various combinations of our vegetation maps. So now I'll be covering existing veg, environmental site potential BPS to potential veg maps. And then after me, Birgit Peterson will be addressing the cover and the height. And then I'll try and clarify. I think Matt introduced folks, if they were here, to our versions. That's one of the things we kind of want to give you a feel for where we're at version-wise, what went into the versions, what we've done to upgrade national, and then kind of allude to what's coming in 10. Just some highlights of that. LANDFIRE National 1.0, circa 01, the product that came out with, and various chunks of it in 6, 7, 8, and 9. Refresh effort that happened through 2010 through 11. We call it 1.05. More or less LF 2001 being a circa 01 with some improvements. And then a LF 8, a 1.1, where we've taken disturbance chronology over the last 10 years and kind of modeled change. And then the update effort, which will be an LF 10, a 2010 circa with updated disturbance from 2001 to 2010. So, and kind of crank through this template here of talk a little bit about the map unit development in national, and then some of the changes we've done to the legend. Very important concepts of getting the things you're going to map up front and working on them, seeing if they're meeting your requirements. The actual mapping, there'll be a fair amount on the technical end of things, probably more information about the national, because we're still more or less leveraging the base veg for national, but we're kind of tweaking agriculture, urban, cover and height. I think Birgit will talk about that was kind of a complete replacement. And then kind of tail end, just kind of going over what we do with the plot data, how it fed the initial effort, and how we're leveraging it back into these existing maps. And again, the kind of map unit requirements that we've kind of been living by in LANDFIRE is this: we plot-driven project. We need to be able to identify those those map units on our plots, and they have to be in categories that are mappable at the scale with the sensors we're using, and then provide us categories that enable us to map fuels and fire regime condition class, all those derived kind of fire ecology projects or products. So when we started, this is kind of the choice we had from a national classification standpoint. A big gap in a mid-level, and a lot of programs face this in terms of the national vegetation classification. The story for us, and like a lot of programs, gap analysis, national park, we kind of filled that interim with NatureServe ecological systems. Now we're looking fairly seriously, and this is probably more relevant to LF10, is this a set of new units, division, macro groups, and groups that kind of fill that middle niche pretty well. So we're kind of alluding to that. But those are some of the things that are affecting our legend issues. Basically, the legend for national was, systems that was the major basis, but we also more or less just kind of pasted in NLCD land cover classes, or rock water, agriculture, urban. The systems were modified in small patch types to aggregates, sparse veg, and riparian wetland. And then, of course, we had to address introduced and rural types that systems don't do, like cheatgrass and modified, plantations and that not. And then we did map a handful of NDC alliances, which were really just kind of below the systems level, a Douglas fir or a mountain sagebrush, just a pure type. When LF 2000, the refresh 0108, we took a little bit of liberty. We had some issues with the burnable ag that Matt kind of alluded to, so we teased out with vegetated urban classes and remapped the urban stuff from NLCD in certain cases into vegetated classes. And then we added herbaceous wetlands. We had an issue with folks being able to identify herbaceous wetland out of our kind of broad aggregated riparian types. Still stuck with the systems, the aggregates, the introduced, and the mappable alliances. And then on the agricultural side, to get more burnable agriculture, we expanded our legend, basically replaced the NLCD 80 series with 10 or so cropland data layer types. So we kind of pasted them in there, and some of those are now burnable and some of those are not, similar to the urban. So basically we kind of just added to our legend. Some of the things we're thinking about LF10 is just kind of more or less a normalization of the whole legend, trying to take some of these types that we've got from NLCD and systems and NBC Alliance and bring them in, line them up, and a lot of that involves mapping them explicitly at a life form level, and then trying to align things so we can go to the new NBCS groups a lot cleaner than we can at this point in time. And I kind of allude to those. That's kind of what you're seeing at a broad level: Arctic alpine, xeromorphic, mesomorphic shrublands, and trees. So that's kind of where we're going from the legend standpoint. The mapping process, just in general, both existing and potential veg, very much just a predictive modeling with classification trees, and this is kind of the steps that folks go through. It's a supervised classification, so your reference data from your plots is up front. Extract predictor variables for each of those reference plots, pull out some validations, plots, some stratification, do some cross validations as you model it, apply the rules in the GIS and make the map. And then a lot of those other, the ag and urban and other kind of set types, we're just kind of pasting on top of there. And the basic ingredients to all that mapping is Landsat imagery, biophysical gradients of all kinds, and topographic, and the reference data. Now this really applies to the existing vegetation. Obviously Landsat imagery is giving you that vegetation signal. And that came from the MRLC kind of circa 01, 3 seasons for every pixel through a date range of actually 99 to 2003, leaf on, leaf off, and a spring scene. And this kind of tracks the process very quickly. That generated a life form mask and then a life zone mask, intersected those two, and then go after kind of within each of those groups actually model the final EVT in there. And this is one map zone here. Some of the kind of improvements then we applied in 01, again, as I said earlier, the cropland data layer kind of enabled us to kind of get at burnable agriculture. We tried to bring the NLCD more or less literally onto our map. We had a kind of hodgepodge from the national effort. Parts of NLCD 01 weren't done. So we tried to line the two up a little bit more, and then that brought in, and then we remapped that some of those urban classes into burnable classes. Kind of had a handful of international boundary issues where we had cut things off. The actual boundary of the country and national really wasn't very well defined, so we got a very official 30-meter boundary of that, and did some other things with riparian. And then like I said, we put in that NLCD, the herbaceous wetlands. And then the fields data, the fields team had actually done quite a bit of work after the initial veg layers had done to map the barriers, as Matt said in the first, the barriers to fire spread, walk and water, and expand on what NLCD had mapped. But those were in the fields layers, not in LANDFIRE National, so we tried to bring those into the LF 2001. And then what we're looking at for LF10, just from a mapping, we're more or less the same thing. We're working a little deeper with the cropland data layer with a little more recent version of it. We're mapping a little more urban expansion with the NLCD 06, so anything new urban on the landscape now gets classified into the burnable, non-burnable. We're addressing a few more international boundary issues, mostly in Alaska at this point, kind of going out to a 3-kilometer buffer around all the coastlines. And then using NWI data where we have it in addition to the NLCD data to get at wetlands and riparian areas, and then still using that fields data, the rock water from that. Potential vegetation, we have 2 layers, and it's the ESP, BPS, the site potential, ESP being kind of the without disturbance, kind of typical habitat type concepts, and then the BPS, probably more widely known because that's what we model our historic kind of snapshots with. That's kind of successional dynamics with disturbance. And different thing there is those are both mapped similar to the EVT, except you just take the Landsat data out of it. Because more or less, your existing vegetation and the kind of mosaic of disturbance on the landscape is an existing veg versus, so really what you end up just more or less doing the same thing with just the biophysical gradients and your reference data. Gives you a little rougher map because of the gradients are defined at a little more general scale. Don't quite line up as well with the EDT map, but I think you start tying it to the EDT map, now you're getting more existing and not potential. And this is an idea, so it gives you some idea of some of the biophysical gradient variables that we use, precip, evapotranspiration. And then again, very similar process to EDT, just the predictive modeling, feed the software, the reference data, and then basically paint a picture of where these things occur according to the biophysical gradients variable. And, this predictive mapping, you can get way in the weeds about it, but just suffice to say that it's a user analyst driven process, but it's in somewhat of a black box, but it's fairly repeatable and it's very sensitive to the data inputs that you have. From the ESP, at least in the West, then we more or less, most of the time, spatially recoded BPS, more or less trying to tier to certain rules in the succession models that we had built that Corey will talk about a little later. So for a given ESP, maybe at a certain elevation band, we split out different BPSs, and then this is to get at the historical perspective, to get at the fire regimes, just different different things involved with the BPS layer that the ESP layer is not telling us. And then some of the things about, the only thing we did was the BPS remap. We kind of focused on the rangelands in the west. Kind of see up here in the corner, we focused on these blue and green zones, kind of an outcome after mapping in the Midwest where Greg Dillon, I think folks know Greg, he kind of headed this team up. They started leveraging Surgo data as they moved to the east and developed a process where basically you take a Surgo map there on the left, look into the MUIDs, and take the eco class categories that are in there, crosswalk them to BPS, and then basically you've got every pixel here now is a potential training site to map. And that was probably one of the biggest reasons that we just had such a dearth of plot data in these rangeland systems, and this was one way to kind of boost that. I mean, it's almost too much. You could ask for millions of plots. I think there was kind of a systematic random selection of about 10,000 plots per map zone. And then a couple of steps where we basically then map. I think the one on the left is the BPS according to the map MUIDs. But then to fill in the blanks in that square you see in the middle there, we just then modeled with the same basic predictor variables we did with the original one, and now we have a wall-to-wall map of that. And then that got spliced into the BPS map. So the last part here, I just want to say a little bit about plot data. I mean, it's important. I don't want to give you the impression that we did at the end because it was front-loaded in the mapping process, but from the classification, mapping, and inventory ideas at the end. So just a few things about the reference database. All part of our process is how do you attribute those plots to your map units? Well, we went through a kind of interesting process, and we developed what we call sequence tables, it was a software package that one of our analysts developed, Brendan Ward, where you come up with, pull the inputs in from the EBT, give it the rules, EBT and ESP table, and then basically it'll apply. So these would be species rules. If you're a certain amount of spruce or a certain amount of fir and you have these understory species and you're in this subsection, your plot now assignment is this EBT and this ESP. So we're able to basically automate the assignment of our map units to all of our plots. So it was pretty crucial because I think as Matt alluded to earlier, we were just kind of going through the plots one by one in our prototype, but we knew, if you saw the numbers that she put up on there, hundreds of thousands of plots, it wasn't. And one of the things we did afterwards, we conducted, actually just recently completed a kind of a validation of that process where we compared the sequence table assignments with expert system assignments and have some interesting results for about 700 or 800 plots per. We divided the country into about 8 or 10 different geo areas. And then we're also kind of maybe taking that further and looking at other ways that we can directly assign NVCS types. That's one thing we're looking at. But it was an interesting exercise. The experts had a kind of high-res imagery, and they had the species table, and they had some idea where that plot was in the landscape, and they assigned it an EVT, and then we compared it to what it had been assigned through at the sequence table. You know, some of the kind of on the back end plot data that we continually get from Brenda, as she said, you know, we had a lot of plots with the initial national, got more plots in the refresh, we're getting more plots now, but as you can see, we're not really remapping per se. The FIA folks, you know, every year they get 2 or 3 more years of data. I think in national we use up to 2003 for refresh. We got 4, 5, 6, and 7, and now we're adding 8, 9, and 10. So these plots are coming in. But what we're doing in some cases for our canopy fuel mapping, for instance, we're basically just building better lookup tables. We take that new plot data, we stratify it by the themes at the mapping level, and re-summarize what crown base height is. So we're kind of leveraging and then kind of update that lookup table. So and there's a lot of opportunity here. Chris, Tony, and I have actually been working with just, I guess what some people would call an imputation process, where we take our existing maps and link them through 2 or 3 different attributes in broad groups, put plots back on the map in various ways, and then look at an attribute of the plot. In this case, it was an FIA forest type. Say, well, now you can make a map of FIA forest type because every plot has one, and you put it on the landscape based on the EVT and the ESP and the cover and the height, and then Chris ran some of these summaries here of just what at a plot level for map zone 19, and then what we mapped, and it shows some promise. You know, I think it would enable us to basically tease out some finer scale attributes. It's not a true imputation where we're starting with a blank map. We tend to leverage our existing maps, but then let these plots just populate the map. So it's another one of those back-end processes where we're leveraging in new plot data onto our existing maps. And that's all I have.